Good evening, students all over the world. You are welcome once again to physics class with Teacher Oge. My experience today during my physical class with some SS2 students on the topic speed, velocity, and acceleration has driven my passion to put up these tips. This is because I noticed that the ability of the student to relate and use these six quantities in physics usually poses great challenge in the classroom. All right, thank you. The quantities are outlined below: the distance, the displacement, the speed, the velocity, the acceleration, and the retardation. Thanks for being there. What is distance? Distance is the space between 2 points. The space between 2 points, or the separation gap between 2 points. Suppose we have 2 points, point A and point B, and the gap between them is 3 meters. This gap between A and B is the distance. Now, because I only talked about the size of the gap, that is the magnitude, that makes distance a scalar quantity. The unit is meter. Then let's go to the second one, the displacement. The displacement is this distance I've given, then going ahead to specify the direction from where I measured from. If I've measured from A to B, I will indicate this with an arrow. But if I've measured from B to A, I will indicate with an arrow. Thereby, we shall be concluding that displacement is the distance covered with a specified direction. Now, have we seen that displacement has both sides, the 3 meter, and the direction? That makes displacement a vector quantity. But the unit there is still meter, because that is the only quantity or the magnitude of the size we measured. Then we go to the third point, the speed. Now, what is now the speed? When we get the value of the distance measured between the 2 points, dividing it by time. In other words, distance divided by time. If I divide distance by time, what I get is speed. If I take distance and divide it by time, I get speed. But instead of dividing distance by time, if I go ahead to divide displacement by time, what I get is velocity. Velocity. All right. Thank you for being there. In revision to what we have done, distance is simply but the space between 2 points. Or we say is a physical quantity that tells us how far an object had moved in space. It's a scalar quantity. Displacement, on the other hand, is a distance you covered, then specifying the direction you took. In other words, is a distance covered with a specified direction. Because of the size and the direction, displacement becomes a vector quantity. Now, if I take the first quantity here, which is distance, and I divide it with the quantity, with the physical quantity time, I have the third one, speed. If I come back and take the second one, which is displacement, and now divide it by the same quantity time, I have velocity. You've seen how we have arrived at the fourth one. Now let's move to the fifth one, acceleration. When the velocity, we move to the fourth one, we shall be using the fourth to define the fifth and the sixth. When the velocity of a body increases with time, we have acceleration. But instead of velocity increasing, instead of me having an increase in the velocity of a body, then I have a decrease in the velocity of the body. I have retardation. So you have seen how we can relate these 5, 6 concepts. Distance, the space between 2 points, just having size. Displacement, that distance you covered and go ahead specifying your direction. Speed, when you take the first parameter and divide it by time, you have speed. Then velocity, when you take displacement being a vector quantity, dividing by time, you have velocity. Now the fifth and the sixth is coming from the fourth. When the velocity of a body is increasing as time increases, you have acceleration. Now, if time is increasing but velocity is decreasing, you have retardation. I believe this will help so many of us on the globe. Thank you for consistently following us. Please always love, like, and share. Thank you. God bless you.